In this video, we are going to talk about the rules in derivative that will help us to calculate derivative in easy and faster way. Okay. If we try to use first principle in every derivative problem, it will be lengthy and tedious. So we have some rules, and these rules are derived from first principle. Remember, these rules didn't come out of nowhere. These are all consistent with the first principle definition of derivative, that is first principle. Okay, these all have some proofs. You can find it in your textbook. Now I'm going to describe each of them. Constant rule means the derivative of a constant term, say a number, will be always 0. For example, if you have a function, let's say you have a function like this. Okay, you'll try to find the derivative of this function. So here is a constant term. There will be a rule that will come later, which is known as sum rule. We will find the derivative of each term. So if you want to find derivative of this term, it will be 0. So that is constant rule. Okay. In second, we have power rule. This is one of the most powerful rule. The name itself is power rule, and it is one of the most powerful rule. It states dx power n with respect to x is n x power n minus 1. For example, derivative of x square will be n. 2 will come down, and the power of x will be 1 less. So for x cube, it will be 3x square. See, for x, it will be just 1, because the power is 1, it will come down, and x power will be 1 minus 1, that is 0. 1 x power 0, which is 1. So derivative of x with respect to x will be always 1. So now let's look at this question. If you want to find derivative of this x square, it will be 2x. And this x, it will be 1. Right. The next one is the quotient rule. It means, let's say you have a function multiplied by some coefficient by dx. You can take this coefficient out because it is independent of x. So it will be this. Now, for example, derivative of 2x divided by x. See, if x is multiplied by 2, so you can take 2 out. It will be 2 dx by dx. The dx by dx is what? 1. So it will be 2. This is the quotient rule. Fourth one is the sum rule. It states if you have two functions as a sum or difference, then it will be equal to the sum or difference of individual derivatives of the functions. It is, for example, we had this question, fx equals x square plus 2x plus 3. Fx equals x square plus 2x plus 3. Let's see, we have to find the derivative of this function. See, this means x square plus 2x plus 3 divided by dx. So we can separate these individual terms like this: dx square by dx plus d 2x by dx plus d3 by dx. There is a constant term, its derivative is 0. This coefficient 2 can come out. Okay? It will be dx by dx, which is 1. So it is 1 times 2. And derivative of dx square by dx is 2x. 2x plus 2 plus 0. This is 2x plus 2. So by combining all these rules, we can find derivatives easily. So we have to learn these rules. We have to get a hold of these rules. The fifth one is the product rule. What if we have two functions in product? We will have to use product rule. It states, let's say we have two functions in product. We'll consider u and v. U multiplied by v. These two both are function of x. And it will be duv is equal to u dv plus v du. Since we are taking derivative with respect to x, it also will be taking derivative with respect to x. What it says is, let's say we have function x square plus 1 and x cube plus 1. You want to take derivative of this function. Now it will act as u and this will act as v. So dx square plus 1 x cube plus 1 divided by dx. This will be equal to, this is u v, u dv plus v du. Again, we'll use the sum rule. So its derivative will be 3x square. This is 3x square. Then the constant term, its derivative is 0. Again, it's x cube plus 1 is dx. Derivative of x square with respect to x is 2x. And for 1, it's 0. So now we multiply these two and simplify, then we get the derivative. Okay. This is our product rule. On 6th, we have, you might have guessed it, we have quotient rule. Quotient means if you have two functions in fraction or maybe division. Now in this, it will be v du minus u dv. Just opposite. Here it was u dv plus v du. In quotient rule, it will be v du minus u dv in additional term divided by v square. And derivative with respect to x. This is our formula. Okay. This, if it was like this, then you'll have to use quotient rule. This is u, this is v. Okay. Now the last one. Last one is the chain rule. Chain rule, what chain rule says is, if we have a function, let's say y is a function of u, and u is a function of x. And you can see, if u is a function of x, then this u is also a function of x. So y can be a function of x. Therefore, we can take derivative of y with respect to x. This will be equal to dy by y is a function of u and u is a function of x. In which you can add the functions like this, du, okay, on the bottom, on the top. Similarly, you can form as long or chain as you like. dz, you can add dz, you can go decay here, decay by dx. As long as you understand that y is a function of u is a function of z is a function of k, and k is a function of x, only then the chain rule is applicable. If not, you can't apply chain rule. Okay, you have to understand that these are functions of each other. That's why you can apply chain rule. Now, you have to understand that these all rules combined is a very powerful tool. Okay, you can apply it to almost all types of algebraic functions to find derivatives. If you try using first principle, it will be harder. Okay. Every time you cannot use your first principle. So these rules will make our life easier. And in upcoming videos, I might use them. We use these rules a lot. Okay. But still, you cannot find the derivatives of trigonometric functions using these rules. Okay, you're gonna find the derivative of trigonometric functions. So we'll have to resort to first principle. Okay. We'll use first principle to find derivative of some trigonometric functions, and then we'll again resort to these rules. For example, we'll find derivative of sin x and cos x by using first principle, and then while finding derivative of tan x, we can write tan x as sin x divided by cos x. So now we can use quotient rule after finding derivative of sin x and cos x. So understand these rules are very powerful, and you have to understand these. Okay, in next video, we'll derive the formula for trigonometric function. Okay, derivative of trigonometric functions. Thank you.